All right. Well, thanks everybody for joining us today. As Nelson mentioned, we are going to be going over a topic that we do touch base on periodically. Every once in a while, we'll do a webinar on these. They are very, very popular. So again, thank you for joining everybody that could join in with us today. We are going to be talking about, as Nelson mentioned, the wiring of commercial audio systems in a 8 ohm and 70 volt. Now, we'll start out with a bit of an overview of commercial audio systems, and some of the applications you might be looking at, what to consider through them, and the differences between 70 volt and 8 ohm. I think that's going to be really one of the key things from this particular webinar. A little video explaining the differences between low Z and high Z, or low impedance versus high impedance, or 70 volt versus 8 ohm, depending on how you want to describe it. Those all kind of fit the same descriptions. And then we'll talk a little bit about 8 ohm wiring and 70 volt wiring as well, and kind of give you some ideas of how the two differ. More of a focus on the 70 volt side of things, because that is more commonly used in commercial audio. But we will talk about the 8 ohm side a bit as well. Now, just kind of a general overview, most commercial audio systems tend to run for long, long hours. Some of them are 24/7. So there are certain audio systems that we install that, or that we've designed and sold, that you install the system and then it literally runs for the entire length of its lifespan. So that could be, in the case of some of these systems, as much as 30 to 40 years, depending on what the application is and that sort of thing. So you want to be making sure that you're using equipment that can stand the test of time, and that's where commercial grade equipment comes in. Typically we run on 70 volt designs, but some can be 8 ohm depending on the application. Particularly for larger facilities, we will like to focus on the 70 volt side of things. Tends to be more of what we're looking at with commercial audio, as we put that in quotations. And there's a bit of a difference between commercial versus consumer versus pro audio. So there's some differences there that we'll talk a little bit about as well. It's generally installed with more robust and powerful audio products in comparison to consumer products. Again, kind of going back to the "it just has to work, it just has to last" sort of thing that comes along with commercial versus consumer. And like I say, professional grade hardware is built to last, so it's going to be able to stand the test of time quite a bit better than a typical consumer level piece of electronics would. Generally used for background music or making announcements. Of course, there's various different applications that commercial audio can apply for, but those are kind of the two of the keys, especially for the things that the TOA works on for the most part. So heading into the next slides, we'll kind of get a look here at how things differ between consumer audio versus commercial audio. And this is kind of an example of what you would expect to see from like your home stereo system, which is going to be, like I said, commercial or consumer audio. So typically what you'll see from your home stereo system, and some smaller commercial audio systems as well that don't operate in 70 volt, you've got a home run back to the amplifier from each speaker. Your amplifier in this case is also acting, based on the image, is also acting as a mixing system. So that's another thing that your home audio system will do a little bit differently than a commercial system. Is typically a home audio system will build in all of the mixing, all of the inputs, everything into the amplifier, whereas in a commercial system we tend to see that separated quite often. Although with TOA we do also have quite a few package amplifiers that can do both. But this is a typical idea of what you would see in a consumer level system. This is also a similar idea to what you might see in a pro audio setup, which is again going to be running on low impedance or 8 ohm speakers for the most part. Whereas in a typical consumer or commercial system, we tend to see scenarios where we're dealing more with distributed audio. We need to have more speakers, and therefore the 8 ohm side of things just doesn't work as well when it comes to the math and the physics of how it actually has to go together. So we tend to create a chain that connects an amplifier to the speakers, and that first speaker connects to another speaker, and so on and so on and so on. So they're just basically daisy chained together, so we don't have to worry about having multiple different speaker wire runs. So this simplifies the setup, makes it easy to expand the system down the road. And so that's a couple of the reasons why we focus on these types of designs more so for the commercial audio side. So some things to consider when designing these systems are things like, where's the system going to be used? That, of course, is going to be the primary concern for the vast majority of these applications. What does it got to do? What's the application that we are selling the system into? So we really have to look into the application itself and really the details of what that system actually needs to do, and hence the what will the system be used for? Is it going to be just paging? Is it going to be background music? Is it going to be performance audio? Because that's a different idea entirely. Presentations. Are we worried more about the vocal range or the musical range? All of these kind of things are questions that we do have to be cognizant of. We're also going to have to be paying attention to amplifier and speaker power that's required. So there's quite a bit of math involved in that, and that's kind of where we're headed with this webinar, is to kind of give you the idea of how to determine what amplifier you're going to need based on the speaker wattage that's required, etc. Do we need multiple amplifier zones, or are we just running a single zone system? Big difference if we're running, 8 zones of paging, where we're paging into each individual zone, or whether we're actually just changing the volumes of each amplifier zone. So there's a couple of different ways of looking at zone definitions, whether it's paging zones or whether it's amplifier zones. What's the wiring that's going to be required? Are we going to be looking at long runs from the amplifier to the speakers, or are we looking at more of a short run scenario? And of course, then we also have to look at performance and cost as one of the big things to consider. All of these things will kind of bundle up together to really drive the design and kind of make the decisions for you as to what direction you're going to be able to take with the design. So to start things off, I'll just hit a little video here.
What's the difference between low and high impedance? Impedance is the resistance to a flow of alternating current. Represented by the symbol Z, it is measured in units called ohms. Speakers are either low impedance or high impedance, and both have a specific job to perform. Low impedance is in a range of approximately 2 to 16 ohms and is often referred to as 8 ohms. Low impedance is ideal for high-performance applications, high-powered speakers, and short cable runs. Low-impedance sound systems are often found in nightclubs, restaurants, and patios, houses of worship, or your home or car stereo. High impedance is typically 25, 70, or 100 volts, and is often referred to as 70 volt. High impedance is ideal for longer cable runs with more speakers per line. Speakers are low-powered with adjustable power taps. It has high impedance outputs with fewer amplifiers required. High impedance sound systems are ideal for public address in corporate, commercial, industrial, retail, or educational applications. We supply sound, not equipment.
So to kind of reiterate, typically speakers are either low Z, i.e. low impedance, or 8 ohm, or high Z, which is 100 volt, 70 volt, or 25 volt. Both of those have a very specific job to perform. And when I look in and we start to dig into the actual details of this, in actuality, all speakers are low impedance speakers at their base. The only real difference between a low impedance speaker versus a high impedance speaker is that the high impedance speaker is going to have a transformer on it, and that allows you to run at a constant voltage like 100 or 70 or 25 volts. So it's a bit of a higher voltage than what you would see on a typical low impedance system. Um, and like I said, those transformers are what's allowing us to simplify the math a little bit, to be able to run on a constant voltage. But technically speaking, all speakers are low impedance. That being said, we tend to differentiate between low impedance speakers versus high impedance speakers when the high impedance ones have those transformers. So that's really what we're talking about, is whether or not that transformer actually exists in the speaker or not. Now, low impedance, as mentioned, is generally in the range of 2 to 16 ohms, often referred to as 8 ohms, 8 ohms being the kind of common, the most common version of a low impedance speaker. The vast majority of low impedance speakers are set with an impedance of 8 ohms, although occasionally you can come across a speaker that's at 4 ohms or one that's at 16 ohms. It really depends on the manufacturer and how they've set things up and how they wanted these speakers to be used. Low impedance generally is ideal for higher performance applications where higher powered speakers are in use, and with shorter cable runs, because you do have a lot more signal loss on a low impedance run than you would on a high impedance run. So typically you really have shorter runs for the low impedance speakers. Also, things like RF interference and that sort of thing can become an issue for longer runs on low impedance cable. Low impedance sound systems are often found in things like nightclubs or performance spaces, houses of worship, arenas and stadiums, or on the consumer level of things, your home or your car stereo. So they all work on the same basic low impedance physics in all of those types of applications. And then you're generally like it shows to the image, you're basically running a higher power short distance directly from the amplifier to the speaker with no transformers in between. Whereas with high impedance, you're typically running a voltage of 25 volt, 70, or 100 volt. And that is a constant voltage that doesn't change based on the impedance on the line. Whereas with an 8 ohm or a 4 ohm or whatever on a low impedance system, the amount of power on the line can actually vary depending on how many speakers and what that impedance actually is. So we don't have the variance with commercial audio in the 70 volt world that we do in the low impedance world. So high impedance is ideal for longer runs. We don't have the susceptibility to RF interference and things like that because we are running a higher power. And that's also the reason why we're able to do a longer run with less drop on smaller cable, is that we are running a higher voltage. So we're not worried as much about signal loss through the system. So tend to be the case that the speakers in a high impedance system are lower powered, and they'll have adjustable power taps on them. And yeah, then there's also usually less amplifier outputs required because you're not having to run an individual cable run for each speaker or pair of speakers as you would on a low impedance system. These types of systems are ideal for public address and background music and things like that in corporate, commercial, industrial, retail, or educational applications. Basically anywhere where you need to have a lot of speakers, but you don't need a lot of amplifiers. You don't have a lot of processing necessarily in most cases in front of them. Um, Although in this case, we're not really talking a lot about the processing side of things. We're talking more about amplification and wiring here. So some of the key advantages with 8 ohm, 8 ohm systems tend to be what you would focus on for designing a stereo system, whereas 70 volts systems are monaural only. So you've got one channel going out from the amplifier feeding all of those speakers, rather than in an 8 ohm stereo system, you would have, multiple channels feeding the various different speakers in a space. So you might have a channel feeding right, a channel feeding left, and that's what you call a stereo image. So those are still actually mono channels, but the way that they've been processed allows them to provide you with an image, and that's what we call stereo, although they are technically mono channels. Again, getting into the semantics more than anything. So tends to be that stereo type systems where you have a left or right center, maybe there's surrounds, those kinds of things. Those are almost all low impedance systems. So an 8 ohm home audio system would have a broad frequency response. Similarly with pro audio and that sort of thing, you're going to have a very broad frequency response and cover all of the different frequencies that speaker is capable of reproducing. Whereas typically a 70 volt system does not have quite as wide of a frequency response. And that's typically a characteristic of the transformer that's being used on that system. Transformers, like speakers, transformers are all not created equal. So some of the transformers you might see out in the world just can't pass as wide of a signal as what you would see going direct to a low impedance speaker system that doesn't have transformers in between the amplifier and the speaker itself. So what that tends to result in is great sound quality. So the best sounding systems in the world tend to be 8 ohm or low impedance systems, again, because we don't have that extra bit of electronics in play that might affect the sound quality one way or another. And there's a lot of flexibility when it comes to speaker and amplifier options for these kinds of systems as well. Now, when we get into the 70 volt key advantages, now this is where it really starts to differentiate the two and where we would use them. So like I say, typically you're going to see low impedance more in consumer audio and in pro audio than you would in what we call commercial audio. So with 70 volt, you're going to get longer speaker lines. You're with the appropriate wire gauge, so you're not worrying as much. I mentioned about power loss on the cable line over those longer runs. All of your speakers are going to be connected in parallel, so there's no series wiring required, which can be the case sometimes with low impedance, although it's very, very rare. There's no need to maintain a specific impedance load to the amplifier. We only have to worry about having a minimum load on there. That's again because we're working with constant voltage and we're not worrying about how many speakers are on the line to affect the impedance that is being pulled, or the power that's being pulled from the amplifier and the impedance that the line then is running at. The failure of a speaker or an open speaker transformer is not going to cause the system to fail. That is, again, because we are wiring in series and we're not wiring in parallel. Just like a string of Christmas lights, if your system is wired in series and you have a speaker failure, well, you're going to have the entire system fail. Whereas if you're running in parallel, you don't have that concern. And so 70 volt is always run on parallel, so we never have the issue where one speaker can cause an entire system to fail. We have a selection of power taps on each speaker, which allows for level adjustment in the different areas of the facility that suit specific zone needs. So that's one thing to bear in mind is when we talk about wattage taps. A 70 volt speaker tends to have a maximum amount of wattage, but you do not generally need to run that maximum wattage unless you have the requirements to do so based on the job itself. So 9 times out of 10, you're setting the power draw of the speaker considerably lower than the max based on the wattage taps that are available on that speaker, and that's not something that's available from low impedance speaker systems. You can add or remove speakers very easily, and it doesn't affect the volume levels on existing speakers, which again is different from low impedance, where if you take a speaker off of a low impedance line, it's going to have a huge effect on the rest of the speakers on that line. Whereas in constant voltage, i.e. low impedance or high impedance, i.e. 70 volt, we don't have that issue. And like I mentioned, using a higher voltage amplifier output allows for the use of smaller wire gauge. So we're not running, 12 gauge wire every which direction to carry our signal. We're able to do that more with 18 and 20 gauge wire, which is obviously a lot more cost effective for use in spaces where you're going to be using a lot of cable. Simple wall attenuators can be used to adjust volumes in each zone as well. That's a very handy thing. Again, in low impedance, you tend not to see an inline volume control because you are getting your power directly from the amplifier with no transformers in there, and therefore you're not running a constant voltage, so it makes it very hard to do a inline volume control with low impedance, whereas on 70 volt or high impedance, it's very, very simple to do that to adjust volumes in each zone. So wiring a commercial system at its base is quite similar whether you're working with low impedance or high impedance. So that first image at the top is basically, something that you would see in any audio system. Before we get to the amplifier itself, we're going to have the input sources, and those are going to have to be fed to the amplifier somehow. Now, in this image, what we're seeing is a combined mixing and amplification system. So you're able to put all of your inputs into that unit, and it's going to mix them together and also amplify them. In larger applications, that isn't generally an option. So you might have your mixing system separate from your amplification system. So this is just a really simplified image of a package type amplifier, of which we have plenty. TOA does a lot of package amplifiers that combine the mixing and the amplification, but for larger systems, typically we will see those things separated. So we're connecting our inputs to the mixer amplifier system, which then powers the speaker chain. And then we can in the case of a high impedance system, we can take the speaker wire from the amplifier output right to the volume control for a zone. Now, as I mentioned, in a low impedance system, that's not really a thing that we would do. We don't really have the inline volume controls in the low impedance system. So I'm going to talk a little bit about low impedance wiring before I get into the 70 volt high impedance side of things, just because typically we're working more with the 70 volt side of things than the 8 ohm. So with 8 ohm, you're going to want to look at how it's wired. There's a lot more math involved in how many speakers can I have on a line, etc. Typically speaking, for the vast majority of applications, you're limited to usually 2, maybe 3 speakers on a single output from an 8 ohm system. Basically, that is because of the way that the math works when wiring 8 ohm or low impedance speakers in parallel. So basically what happens if you're wiring in parallel, you're going to have 8 ohms of output on a typical single speaker setup, but then when you add another speaker onto that line, that goes to 4 ohms. Now, this is where we have to be really careful, because if you were to add a third speaker onto that line, you're going to come to somewhere in around the I think it's around 3.2 ohms, something like that, if you're working with 8 ohm speakers. And then if you were to add another one on again, you would be getting to 2 ohms or even lower than 2 ohms. And that is where you start to get into some really dangerous territory when using low impedance amplifiers, because most low impedance amplifiers are really not designed to go much lower than 4 ohms. So basically what ends up happening is if you start driving that impedance lower than 4 ohms in an amplifier that's not designed for it, basically you're designing a system in which your amplifier could double as a hot plate to fry your eggs on, because you're going to cook your amplifier. So you have to be very, very careful with how many speakers you put on a low impedance output. And that's one of the main reasons why we focus more on 70 volt or constant voltage for commercial audios, because we can put way more speakers on these lines without having to worry about the amplifiers themselves. So that's just kind of one look at how we would do things with an 8 ohm system. And this is, like I say, a very common way of doing performance spaces, gymnasiums, all these kind of things where you need higher power per speaker, but not as many speakers, because you are going to get that higher fidelity. You just, like I say, you have to be really more careful about managing your speaker count per amplifier. Now, conversely, wiring low impedance speakers in parallel does the opposite of what wiring them in series rather does the opposite of what wiring them in parallel does in terms of the mathematics involved. So in a series setup, which is again incredibly rare, you almost never see series setups external to a speaker cabinet itself. Um, the only reason to use series for any speaker system, particularly low impedance. In fact, it's not even a thing you can do with high impedance. But with low impedance, the only reason you would do it is to manage your line impedance and give yourself the ability to add more speakers to the system. So it's fairly common to do this internally to a cabinet that has more than one speaker in the cabinet itself. So if if you're looking at a pro audio speaker cabinet that has 3 or 4 drivers in it, chances are some of those might be wired in series internally to the speaker where you can't see it, just to keep the impedance where it needs to be, so that all those speakers kind of, the math works out that all of those speakers add up to 8 ohms. So you might have 4 speakers in there, but some of them are wired in parallel, some in series, in order to manage the math. But very, very rare would you ever see a series connection external to a cabinet. So you'd never see, an amplifier with an output running to a speaker that then chains on to the way that we're seeing wired here. 99% of the time you'd be wiring in parallel when it comes to the external side of things. So this is something usually you would only see internally in the construction of a speaker cabinet. So getting into wiring a high impedance commercial system, well, that's going to be, again, like I say, totally different from a low impedance system. So basically you've got your speaker wire from the output and now we're taking off from the volume control. So you've got your amplifier feeding power into the volume control, which then is passing that into the speaker system. So makes it really quite simple. And that attenuator then is going to just sit on the line, and as you make adjustments with the volume control, it's literally changing the amount of power that's being sent to the speakers. You can also then keep connecting speakers this way to scale up your commercial audio system. As long as your amplifier has the power capacity to add more speakers on, you can add speakers to the line to your heart's content, and without really changing anything about how the system functions, the overall volume, et cetera, et cetera. You're not changing the impedance on the line, so you're therefore not changing anything about how the speakers interact, except for adding more. So this type of system obviously simplifies your connections, saves you a ton of wire because you're not running home runs to every single speaker, and of course saves on amplifier power as well, because you're not giving a separate channel to all of those different speakers or all those groups of speakers. and it's designed to run all day, every day. Again, you're not running with a lot of variations in the power. You're not putting, different amounts of draw on the system throughout the day. You're just kind of letting it go, and it's just always kind of functioning. So what you see here is actually a spliced line, so a spot where we've got one output from the amplifier, but we want to have control of volume on two different areas. So what we've done here is this is just a basic splice on the speaker line, sending one side of the splice out to a volume control and out to the speakers from there, and then the other side of the splice to a different volume control and a different set of speakers. In this case, and in any case with a high impedance system, you're going to see about 99% of the time you'll see a wattage tap on the back. It's generally a little switch or a series of different connections that you might use that will indicate what the wattage requirement, what the wattage pull is going to be from that speaker. So you can generally set that. It depends on the speaker. It might be, you've got in this case, it's the attenuator or the wattage tap you see there would be for a speaker that has a max power output of 16 watts at either whatever output impedance that you've got it set at, whether that's 100 volt or 70 volt or 25 volt, depends on the speaker. But in this case, you're seeing a max tap of 16 watts with smaller taps that you could look at for 1 watt, 2 watt, 4 watt, 8 watt to put different power outputs into the system. So when it comes to wiring this stuff, high impedance makes it really quite simple to do the math. Whereas with low impedance, you were worrying about, oh, what's the impedance when I have this many speakers on the line versus what's the impedance when I have that many speakers on the line. You don't have to worry about the impedance as much. So all you're really worrying about is the amount of power that's being drawn by the speakers on the line versus the amount of power being output by the amplifier. So you might have 10 speakers that on the line that are all tapped at 4 watts, as you see here in the image. That's going to give you a total of 40 watts. 4 times 10 equals 40. Very, very simple to do that math. So it's one of the reasons why commercial audio is set up this way, is because the math is just so much easier to do when it comes to putting a lot of speakers on a single line. Excuse me. We always recommend also to choose an amplifier that has plenty of power left over to give you what we call headroom. Not necessarily to expand the system, but more to protect the system in case of peaks and valleys. So audio has a tendency to peak every once in a while, and what that means is that it's going to drive a little bit of extra power into the system, and that headroom is going to allow the system to absorb those peaks without having any excess pressure on either the speakers or more particularly on the amplifier. If you're running things at max on the amplifier, if your system peaks, then you're actually overdriving the amplifier. You're potentially damaging the amplifier. So you always want to have at least 20% of headroom as a general rule on any system, whether that's low impedance or high impedance, to give yourself the extra headroom for either expansion or a 70 volt system, or to handle those peaks and valleys that we see with a typical audio signal. So wiring it, very, very simple. You're going directly from the positive of the amplifier to the positive of the speaker to the positive of the next speaker to the positive of the next speaker. Negative from the amplifier goes to the negative of the first speaker, goes to the negative of the next speaker, goes to the negative of the next one, and we don't have to worry about doing a loop back like we would with series to the amplifier. Basically it's a straight line that's terminated by the last speaker in the line, so we don't have to worry about looping everything back the way we would in a series system. And like I mentioned, all 70 volt systems, all the high impedance systems rather, are wired in parallel, so we never have to worry about having the entire system drop if one of the speakers happens to die throughout the system. So in this example, what is the power draw needed for this product? What kind of amplifier am I actually going to need? So we have 50 speakers in this system, and they're all set to 2 watts each on the wattage tap, so that equals 100 watts. If we want that extra 20 watts headroom for safety, then we need a 120 watt amplifier. Fairly straightforward. So that's the basis of how the mathematics works when it comes to a high impedance system, and that makes it really incredibly easy because you can apply this, whether you're using 100 speakers or 1,000 speakers, the math is basically the same. And then you take your total wattage from the speakers that are on the line, add 20% to that, and that's the minimum power wattage that you'll need from the amplifier. So now we have a more complex scenario with multiple zones. Now you'll have to envision that there's actually a line running from the amplifier to each of these zones. Now, in this case, if it's just a single channel amplifier that's powering these zones, then what you're going to have is separate volume zones. So you might have one channel that's being spliced, like I showed in the image earlier, to send to each of these separate volume controls. So, zone one, you've got a volume control that's followed by a 15-watt tap and two 7.5-watt taps. So that's 30 watts on that line behind this attenuator. Then this line here, the second one, you've got an attenuator feeding 3 watts of speakers, and then on the third zone we've got another attenuator feeding another 60 watts of speakers. So those could be, like I say, a single home run and spliced as from a single output of an amplifier, or if those need to be separate paging zones, separate content zones, then you would actually have to have separate amplifier channels to be able to run those zones. So again, differentiating between the terminology of, is it a volume zone, or is it a paging zone, or even is it an amplifier zone? So some of those things can be a little foggy if you're not 100% sure which type of zone you're trying to determine. Yep, so you'll need to determine the power handling for each of the volume controls for the speakers that's connected to it. So like I mentioned, um, in this case, zone one, we're running 30 watts of power, so we need an attenuator that can do 30 watts of power. So in our case, with TOA, it actually wouldn't be a 50-watt attenuator. We don't have one of those, so we would have a 100-watt attenuator on that. Whereas with the small zone, the 3-watt zone, you would be able to run an attenuator that has a lower power maximum available to it. So that would be, in our case, the 25-watt volume control. And then when you've got the 60 watts of power, you're back to the 100-watt volume control. So your volume control is going to have a maximum amount of power that it can pass, and you want to make sure that you're using the appropriate volume control to be able to handle that amount of power. If there's more than 100 watts on the line, then there's a very good chance you may not be able to use an attenuator on that line, and you would be just relying essentially on the volume control that's either at the amplifier itself, for the amplifier's output volume control, which generally we tend not to want to change. More likely you would be changing that volume as an output to that amplifier channel from the mixing system when you're dealing with that much power on the line. So we do max out for TOA in terms of wall attenuators that you can put in line at 100 watts. You can't really do a wall attenuator with a higher wattage output than that as the total. So next we're connecting, so we're connecting the other two as well. So we've got these all connected basically in parallel as well. So in this case, we are splicing a single output to be able to feed these 3 separate volume zones. Now, like I mentioned, these are not paging zones. These are amplifier or volume zones. So these are all going to have the same content. They're just going to be able to have various different volume levels based on the attenuator that you have on that line. So again, back doing the math, how powerful an amplifier do we need? Well, we've got 30 watts on one line, we've got 3 watts on the next line, that's 33, then we've got another 60 watts, that's 93. 120 watt amp is exactly what we need for that. We wouldn't want to go to 100 because we're lacking that 20% of headroom. So we want to go to the next step up, which is the 120 watt. Now, one thing to bear in mind with high impedance systems, if you're in a certain scenario where you maybe don't have 120 watt of amp available to you, but you still want to make sure you have that headroom, it would be perfectly acceptable to use a 240 watt amplifier on this because again, the amplifier's output power is not going to change what the speakers actually see. So in a pinch, if you don't have one that's, exactly the wattage you want, then you'll want to go to the next step up to give yourself that extra headroom, not go back the other direction. You don't want to go back, if you're running a 100 watt system, you don't want to go say, okay, well, I can't get 120 watts, so let's go to 100 watt. No, you would actually want to go from the 120 to the next step up from that. So that begs the question of what wattage tap should I use on my speakers? That is going to depend entirely on the installation. It's going to depend on the background noise. It's going to depend on how many speakers are in the system. It's going to depend on how far do they need to project, like the distance between the speaker and the listener. And one thing to really bear in mind is every doubling of wattage is really only going to increase the system volume by 3 decibels. So that's something that we always bear in mind, where we'll have, quite often I'll have people asking, okay, well, I've looked at 15-watt speakers for this, but should I go with the 30-watt version instead? And really the answer to that is you can, and it will be slightly louder. It will be barely perceptibly louder. That's what 3 dB actually is. So that's just something to bear in mind, is that doubling the power may not have the impact that you might think that doubling the power would have. It's going to make a difference of exactly 3 decibels to any given system. That's just how the physics of it work, and the inverse square law, etc. So also noting, increasing the tap wattage of the power requirements is going to change the amplifier requirements. So again, you're going to want to be paying attention to what those wattage taps are set at and what you actually need them to be set at, to make sure you're designing the most efficient system possible based on its actual requirements, and not overpowering it to drive the number of amplifiers, the amount of power the amount of power that those amplifiers needs to provide way up, and of course increasing the cost when it may not be necessary to do so. So again, paying attention to where those wattage taps actually need to be versus using the full wattage of what might be available on the speaker. So that's it for the most part on a quick look at how we wire those systems. I hope it's been very, very informative. I do want to touch before we finish off on our free design assistance services. So that is something that TOA Canada does on a regular basis. If you've got a system that you need some support in designing, by all means, bring it to us. We will be able to help you put that system together. We'll take you through some initial questions. In fact, we've got these 2 forms on our website that can take you through those initial questions as to, what does this system actually need to be able to do. So that you can fill those out, submit them into either tech support or to your local RSM, and we will be able to take and help you out with those kinds of scenarios, to kind of take some of the guesswork out of how to design these systems. So that's a service that's always available to you free of charge from TOA Canada.
Dr. Sound. TOA.